personal views and opinions expressed by our podcast guests are their own and are not legal advice or official statements by their organizations. Hello, my name is Debbie Reynolds. They call me the Data Diva. This is the Data Diva Talk Privacy Podcast, where we discuss data privacy issues with industry leaders around the world with information that businesses need to know now. Today, I have a special guest on the show, Kurt Cagle. He is the founder and CEO of Semantical, LLC. He's also the editor-in-chief of the popular Cagle Report, which is a newsletter on LinkedIn. Definitely check that out. And he's also the community editor of Data Science Central. Welcome today, Kurt.
Thank you very much, Debbie.
Yeah, I have been really interested in, I guess I started to know you on LinkedIn from your Cagle report. So I subscribe to your newsletter, and a couple fascinating things that you do in your newsletter. I like them because they're kind of like long read things, and you really sort of traverse a lot of different topics. So it's not just technology, not just data. So I like the fact that you kind of multifaceted and you can kind of talk about different things. I think it helps that you're, a writer, editor, a novelist, ontologist. Those things are really cool to me. So why don't you tell me a little bit sort of about yourself and your journey to where you are now in your career?
Okay. I started out many years ago wanting to be a physicist. And, when I was a kid, I thought the whole idea of describing things as both waves and particles to be just really fascinating, which tells you probably more than you need to know about me as a 13-year-old. So went off to school, got a degree in physics, but spent probably a good 80% of the time actually in the computer lab, because this was back in the 1980s, and all of a sudden you had these great, wonderful portable computers, which was a really, really novel thing at the time. Despite the fact that I spent most of my time in the computer, I did get a physics degree and discovered very quickly that in 1980, a physics degree, bachelor's degree, was absolutely worthless for anything other than going on and getting a master's degree. So I kind of took advantage of the fact that I'd spent most of my formative years in college working on computers, and went into computer graphics and worked with PostScript, and worked for a while with a couple of ad agencies and things like that, doing their computer graphics work. And then from that, made my way into computer gaming back in the early 1990s, and shortly thereafter, kind of spent a little while doing gaming work, and probably about 5 years doing gaming work. And then that was about the time that the web hit. But while I was doing gaming, one of the things that I really concentrated on was increasingly, how do you represent data? How do you represent information within your applications? How do you store it? How do you work with it? How do you structure it? Because databases were these big, complex things that you saw in commercial organizations. But for the most part, what I was interested in was basically small data. It was data that was essentially comes from external sources, but is something that you can basically utilize as a structure. About the same time, Tim Berners-Lee had kind of moved on from the XML working group and the HTML side of things, and was beginning to explore the semantic web. And his notion was, again, basically saying, if I have a If I was to basically represent information as concepts that each had a specific name, where that name was essentially unique. So not just a name in terms of the words that we think about, but name in terms of a unique identifier, what we would call a GUID today, or a uniform resource identifier. Then we can think about information as being made up of these names connected by links to other names that represent things. Well, when you start to deal with names and properties that those names describe, and say, okay, I have here is a book has an author, it has a title, it has, these chapters and so forth. That entity that we're talking about has a specific name that is unique or can be made unique. Not just in terms of a unique key in database, but unique globally. And so all of these pieces basically started coming together, where you could then say, okay, if I have nodes connected by labeled properties to other nodes, what I've created is what's called a graph. And so the semantic web ultimately was about building graph technologies. So you could think about REST, and you could think about URLs as being locations, but they could also be thought of as names into this graph. And navigating across that was essentially navigating through a conceptual map of information. And that was essentially the beginning of the semantic web.
Yeah. I just want to back up a bit and make sure that people understand. You kind of answered a bit of a question I was going to ask, but I want to make sure people understand what the semantic web is and how it's different than maybe what they think it is.
Okay. So first of all, semantic web sounds scary. In fact, there's this whole space talking about taxonomies and ontologies and semantics and other big, scary Greek and Latin words that most people kind of look at and go, I'm not so sure about this. It sounds more like philosophy than it does programming. And to a certain extent, that was kind of largely an accident of where it came from, because a lot of this was essentially the idea of basically connecting things in a graph has actually been around for a while. If you look at any kind of structured entity, any kind of structured data, that data can be thought of as a graph. And depending upon whether that graph is tree-like, like most documents are, or whether it's something that's more connected, more intricately connected, what you end up with is either, there's terms that get thrown out. These are all things like directed acyclic graphs, or DAGs, and directed cyclic graphs, or DCGs, and things like this that really kind of only an academic would love. But the idea behind it actually is pretty simple, and that is that you have information, you have things that you're describing. And one of those things that you're describing basically has a property, or has a set of property or metadata that describes a thing's type, or its class, or its characterization. And so you can basically start using what I would call logical formalisms, but for a typical reader, you can think of it as logic, as ways of being able to say, here's a set of assertions, and if this assertion is true and this assertion is true, and the object of one assertion is the subject of another assertion, then you can start making reasoning on that information. A good way of thinking about it is I can basically talk about I have a brother, and that brother and I happen to share a father. So there is this relationship that basically exists where I can define that relationship in terms of other things. I can say, okay, if I have the concept of a father and I have the concept of a sibling, and that sibling has the concept of a gender, then I can say, if I know that this person is my father, and this father and this other person is also also has that same father, then I have a relationship. Now, same thing applies up on the mother's side. It gets a little more complicated when you start talking about genealogy. But the idea is that these relationships that you're defining are things that can then be tied into categories. So, you can talk about this in terms of, okay, I have the class of people, and some of those people share these relationships, and because they share these relationships, I can identify those patterns of those relationships, and with those patterns, I can basically start querying and building inferences and definitions. So, if I then go and say, I have a relationship for my father, and he also has a father who has another brother, then I can define in terms of that this relationship that says this person is my uncle. So a lot of the semantic web, when you get right down to it, is basically talking about classes of things, people, animals, pets, buildings, locations, books, ideas, whatever, and the relationships that they have. And those together, once again, make up a graph. They make up a way of storing information. Now, we've been doing this actually for a while. It is possible way back in the late 1970s. You had Ted Codd, who was one of the instrumental, was one of the instrumental people for creating relational databases in the first place. And he wrote fairly extensively about it and introduced the notion of what would become SQL. And he said, these are still graphs. These are still things that we can talk about. However, at the time, the capabilities of what he was working with were just not sufficiently strong enough. They just weren't fast enough, to be honest, to actually talk about more complex structures beyond, here's tables and here's rows and here's columns. But you can kind of think of a graph as if you were to take these tables and rows, and each row essentially becomes an identifier for a thing, and each column then becomes a property, then there is a relationship that gets formed, and that relationship becomes essentially becomes a graph, becomes a way of describing entities at a basic schematic level.
Right.
So I'm not sure if that necessarily helps in the understanding, but the idea really is when you talk about semantics, what you're talking about are these relationships and how they build with one another.
So is the purpose of the semantic web to be able to have um, organizations or technology be able to create, make decisions faster?
Yes, among other things. You can kind of think about it as when you're storing information, and this actually gets into one of the distinctions between two different versions of AI. One of those versions is essentially classification, where you say, I have a bunch of pictures of cats and dogs and other pets. And each one of these, we're going to run through a process, and we're going to basically do these image recognition pieces to be able to identify certain characteristics. And we work with a labeled data set that identifies, okay, this is a picture of a dog, this is a picture of a cat, and we've got 10,000 of these pictures. And that happens to work pretty well when you're starting to talk about information that is, categorical in nature and is largely dependent upon identifying certain patterns. But it's a very brute force method of being able to get information. The problem that you run into with that is that as you are working with this, you can say, this is a cat, this is a dog, this is a rabbit. But unless you have specifically added into this some kind of relational factor that says, okay, a cat as a pet is an animal, a dog as a pet is an animal, that kind of information gets lost. And when you start talking about semantics, you can start building up relationships, things like taxonomies, Linnaean taxonomies, for example, where you can say, okay, if I can identify this thing as a cat, then I also happen to know that it's an animal. I know that it needs to be fed because animals need to be fed. I know that it needs to be registered because pets need to be registered. Because pets need to be registered, I need to have a registering body, and you start building these relationships that exist about this kind of interrelationship information. And it is that kind of information, that categorization aspect, that's actually very difficult for machine learning to be able to facilitate. So one area that semantic web really helps is that it kind of provides a convenient index, or what's called a rubric, for identifying certain concepts. And those rubrics are a lot like the kind of rubrics that you have. As an example, for the Dewey Decimal System is a pretty good example. Okay, Dewey Decimal System basically was a classification system that was developed in the early part of the late part of the last century. Actually, late part of the 19th century. And it essentially said, okay, we're going to take all of knowledge and we're going to assign all of knowledge to different numbers and different collections of numbers. So you say 00 through 099 or 099 is a description of basic philosophy and gets into other areas like mathematics and stuff like that, but not completely. You talk about the 400s, and those are generally sciences, mathematics, physics, chemistry, biology, whatever. But each of those numbers essentially are a classification system. Now, I could take a machine learning system and say, here is a book, and that book includes a um, Dewey Decimal System, a DDS number. And from the structure that we're talking about, I could actually infer to a certain extent, after I have a lot of data, what that structure looks like. But it takes a lot of data to be able to get that inference right. Or I could basically say, okay, there's a classification scheme that I'm using called the Dewey Decimal System, and it has these numbers. And as you are classifying this information, you can basically use these numbers to be able to identify, given a certain set of topics, where this book goes. And so one approach, that bottom-up approach, is really how machine learning works. The top-down approach, where you're basically saying, I'm creating a structure for information, that is essentially an example of a top-down classification system or taxonomy, or in a little broader sense, an ontology.
Yeah, that's fascinating. So let's talk a bit about the individual. So because I am very interested in privacy, right? Kind of, just the legal and technology issues. The way that you describe kind of the semantic web and the different ways you just talked about, like being a bottom up versus top down way to look at data, is interesting, because I guess you can have problems in both, but I guess the thing that concerns me a lot related to privacy or individuals is that if a person doesn't fit neatly into a category, or you can't really, if there are sort of outlying information that can't really respond to, a particular categorization, I think that is sort of a way that kind of bias can reveal itself in data. What are your thoughts?
Absolutely. And that's true for both kinds of technologies. With when you get into machine learning, which is really where I'm spending a lot of my time now, what you're doing is basically saying, I'm going to take a data set, and that data set is then going to be used to run through essentially for one of a better term, a neural network. This is kind of getting at the upper edge of analytics, but it's run through a neural network, and that neural network is then going to take that information and utilize it in such a way that it says, okay, I've done my classification or a priori classification that essentially identifies the kinds of things I'm expecting to find. This is how I'm labeling this information. And when you talk about labeling, what you're actually talking about is classifying. It's different notation because they kind of came up from different directions. But the idea in both cases is that you have various classification systems, and then you can effectively say, if I take this and I shard the space up into various places where you have concentration of information, then that basically represents a thing. And depending upon the kind of machine learning that you're talking about, you have some types which are essentially labeled and trained. You have some which essentially do the training afterwards, or do the labeling afterwards. So you essentially identify clusters of information and then say, okay, I'm going to interpret this in this way. But both of them essentially work in much the same idea of saying, okay, we're going to identify these clusters, and based upon the clusters, we will then essentially say, here are the rubrics that we're talking about. Here are the categories that we're working with. The problem with that ultimately is that it really comes down to the data set that you're utilizing. And one thing that an ontologist does, and I'll jump into what an ontologist is in a second, or what an ontologist is in a second, but one thing that they do is that they actually try to make their models as unbiased as possible. So they look at edge cases, they look at places where there are certain constructs, and they say, okay, what about this particular case? Does it fit neatly into this set of attributes that can effectively identify something? If it does, then that's great. You have a classification, you have a mechanism to say, here is a concept that we're going to want to call. This is a cat, this is a dog. But sometimes you get foxes. And foxes are really problematic because if you don't define those foxes, but you basically go in and say, here is the classification system that I've created, then they tend to get misclassified. That creates bias because a cat is not a fox, a dog is not a fox. They both have similar characteristics, but they're different animals, they're different species. And so from a machine learning perspective, on the other hand, if you have these foxes and you basically misclassify or miscategorize, that also creates bias. The danger there is that sometimes that bias is a lot more hidden because you don't necessarily have someone that is acting as a governor of the concepts that you're dealing with. And so, and admittedly, it goes both ways. People have biases when you start putting things in. And a prime example of this is when you talk about gender. The FBI currently has, according to the National Information Exchange, currently has 17 different classifications for gender. They've tried very hard to be able to look at all of the possible edge cases that still are large enough to be able to handle more than a single individual. Simply because, yes, you're always going to have people that end up in the other bucket, but you want to make sure in your division, in your ontological design, that the other bucket has as few members as conceivably possible. And if there's something where you look at that other bucket and say, okay, this happens to be a platypus, then you can essentially go in and say, maybe this thing isn't really a mammal at all. And in fact, if you talk to biologists, they will say, yeah, platypus really isn't a mammal. It's kind of it's kind of somewhere between a bird and a mammal, but it kind of is its own little line. But because there are so few of them, it tends to get lumped in with the larger groups. And so this is one area where bias becomes a fairly significant area is in that particular classification.
Yeah. So a dear friend of mine, David Walker, did a reverse image search on the internet. He has a famous profile picture of him in a yellow polo shirt and a baseball cap. I think it's like a Marine cap or something. It has like a little yellow in it. And so he did a reverse image search, and it came up with pictures of men in baseball hats, and not all of them had on yellow shirts, but there was some yellow element in it, and it was like guys of all ages and all races. So, and as a novelty search, right, that's not a big deal. but like if the same technology and thinking and logic is used in something like a facial recognition database, that's a problem, right?
Well, and what makes that even more problematic is that um, you have competing interests, each of which has a particular desire to use that technology in a certain way. And, image recognition is certainly a big one. Particularly since image recognition is actually, first of all, relatively easy to spoof. There was some um, very interesting studies done, which kind of became a meme at one point, where people would actually put bars of paint on their faces at strategic places, and it would just completely confound the the image recognition systems. It's kind of like, I don't know what this is. I don't know who this is. And additionally, even with that, you get into the question of why or what purpose are you using this for? Image recognition by itself is a pretty cool technology. Hi, Dave. You may open the pod door now. But this gets into an area where you basically start talking about the implications of artificial intelligence in particular, within the ethical constraints of a society. And yes, the problem that you run into with that is that, again, good data is relatively hard to come by. This is actually one of the great myths of the big data era. Yes, there's a lot of big data out there. Most of it's garbage, because most of the data that you're dealing with does not actually come about for the purposes of being able to do the kind of classifications that you're looking at. Most data, the vast majority of all data is created as transactional data. The records that you keep from transactions. What you generally don't have, because it gets into the arena of privacy, and it gets into the arena of what is the public's right to know, is essentially that metadata that describes what's on each end of that transaction. Who these people are, what are their interests, why are they? That's something that marketers love. That's the information that they live for. They want to be able to get that information. But it's also something that, for exactly the same reason, many of us don't want to have happen. And that's because essentially it becomes a question of who owns that metadata, how do you access that metadata, who has access to that metadata, and under what circumstances.
So what is your biggest concern right now around kind of data privacy and just data in general? I don't know about you, but I feel like we're going in two different directions in some way. So I feel like the laws are trying to give people more transparency and more kind of agency with their data, attempting to. But I feel like the data, we're finding new ways to collect even more and more and more data. So I think we're kind of chasing the technology or what's happening with data right now. What are your thoughts?
Yes, absolutely. I think that there are a couple of conundrums that we're facing right now. One of them is in the arena of inference. And inferencing is actually one of those areas that, from the semantic standpoint, inferencing is a fairly major part of developing any kind of a knowledge graph. The problem with inferencing is inferencing basically is specifically designed to surface information that was not known previously, or at least was not known in a whole previously, until you get enough information together to be able to identify that. So, an example of this is I can probably, with about 5 pieces of generic information, your zip code, yeah, your zip code, your age, your what kind of car you drive, maybe 3 pieces of information. If I have those 3 pieces of information, I can probably manage to whittle down a list from potentially millions down to maybe a few dozen people. And it doesn't take much for that inferencing process to get to the point where, even if you have clean data, even if you have data that has been run through PPI, has been PHI information, personal health information, personal privacy information, and so forth. Even if you have that information in place where you've cleansed the data set, the problem is that it doesn't take much to be able to give a fairly high degree of probability that a given individual is in fact the person involved. And that is going to be the bane of privacy experts for pretty much the foreseeable future. Because you don't the ability to basically stay anonymous is so completely compromised at this point that it's meaningless. And this was a discussion that I had with a number of health experts during the early days of the pandemic, and specifically talking with people in the European Union. And the problems that they ran into was that they had the data, they could inference the data, they couldn't legally utilize the data because that data, the laws that were in place, were laws that had not really taken into account the speed at which this technology has been evolving. And so, you've got a lot of what's going on with GDPR. You have a lot of what's going on with the California data initiatives and so forth. Both of them, they're well intentioned. I'm just not sure that they're actually going to be that effective. And I think that's a real challenge, moving forward.
I'm glad that you brought up inference, because I feel like inference can be extraordinarily dangerous if, depending on how people are using inference, right? Especially as what I'm seeing is people using technologies that were developed for one purpose and trying to shoehorn it into another purpose that may create inferences that, as a result of inference, companies or organizations may take life or liberty actions against people that could be harmful.
Mm-hmm. Well, I think a good case in point there was the actions of the Cambridge Analytica. I think that should be Cambridge Analytica should be a case study for anyone who is involved in the ethics of privacy and information. Because what you had in that particular case, drawing a blank on his last name, Robert Mercer, basically set up a company that essentially utilized the mechanisms of inferencing and push polling and pulling information to essentially create profiles. And this is what any campaign data organization does, but then was essentially utilizing it to generate misinformation that would then be targeted to the candidates or to the potential voters of candidates in question. And it was unfortunately it was very effective. And it was very effective even though it wasn't really all that terribly ethical, because it kind of gets down to a lot of the ways that we tend to think. How, unfortunately, human beings don't like to admit this, but they can be programmed. And they can be programmed primarily in certain ways by repetition of information, by creating certain conditions that tend to lead towards conclusions that are erroneous, but by effectively controlling the space, the information space around people, and by eventually subsuming them in that, allow them to be captured. And this is likely to continue to be a problem because we have tools, both the bottom-up tools that you see with machine learning, the top-down tools that you see with semantics, where you can not only identify, but you can also social engineer a response back into society that is very worrying. And I think that to me was one of the big problems that I saw in this last administration, the Trump administration. I'm not going to get too political here, but the Trump administration basically used a lot of the same kind of mental control mechanisms, largely predicated upon understanding and control of a fairly tightly constrained information audience, to be able to significantly change the way people thought. And there's a term for that, the Overton window, what gets discussed and how it gets discussed. And this is actually a fairly critical aspect that, from a perspective of being a journalist, is very important to me, is that, when we're talking about this kind of information, it really that kind of does then come down to, okay, what are the ethical boundaries? Where do you basically draw the line between telling what happened and influencing the thought process of people? And it's one of the reasons that I think that while it's never going to be a terribly lucrative area, I see the ability of journalists and influencers to be both, inescapable and fairly pernicious in terms of the overall effects that it has upon society.
Interesting. I would love to know, if it were the world according to Kurt and we did everything that you said, what would be your wish for privacy anywhere in the world, whether it's law, technology, anywhere?
Well, nice, simple questions here. Um, I think one of the things that we need to do is to develop a mechanism to effectively identify, what's the best word here, to identify the provenance of information. And from that, to start making sure that the mechanisms that we have for the transmission of that information, of that knowledge, effectively, because they are increasingly becoming digital, have some mechanism to be able to say, this information is biased, this information is not, this information is biased in this way, this information is relatively neutral. And there are pieces that possibly make that possible. A lot of the work being done right now with blockchain or other distributed ledger technology is one precise example of that, where you can say, this is where information has been. This is what establishes the trail of authenticity. It is also the same kind of mechanism that's needed for creating certificates of authority or for building authority. Now, you get deep down, and one of the things that you discover about the way that we build and we have built our society is that we don't have a good solid concept of how to deal with trust in a digital environment. And I'm not really sure that we can. I've actually been something of a skeptic about self-sovereign authentication and self-sovereign systems, primarily because I believe the biggest problem they have is that they don't necessarily provide the ability for someone to sue someone else based upon the lack of authentication. And that's actually very important. I mean, it may sound, oh God, that's what we need is even more lawyers into the mix. But ultimately, what it does come down to, and I think this is what trust comes down to, is that trust implies a certain degree of liability. If I assert something and you do something based upon that assertion, and it turns out that you basically cause damage, where is the responsibility for that? Is it in you or is it in me, the person who provides the assurance, the surety, or is it in the person who accepts the surety? And I think that you need to have that. It's a social construct. It's not a programmatic one. And I don't think you can build a programmatic construct, at least not yet, that is capable of managing that surety.
Wow. That's a heck of an answer to that question. That's wonderful.
I mean, I've been thinking a lot about it. I think that it's something that we need to be very careful about, because there is so much of a temptation to want to use technology to solve sociological problems. And unfortunately, technology doesn't solve social problems. Technology only facilitates the means by which people can accomplish things more efficiently. If those things are wrong, then they're wrong more efficiently. It's what it comes down to.
Right. Well, this was wonderful. Wow, I can listen to you talk for hours, and I highly recommend that people go on LinkedIn and subscribe to your Cagle Report newsletter because it's always fascinating, and I love the fact that you mix it up. So it's not always about, it's just different stuff. Like you've done some fascinating things about names and naming. You all have to find that. It's really good. So go on his LinkedIn under articles, I believe. That's where your newsletter shows up for people, and definitely subscribe to it. So thank you so much. I really appreciate you being on the show. This is wonderful.
Thank you.